Okay, a very good morning to Dr. Ilyani and fellow friends. Now today, we Group 12 are going to present to you our linear algebra group assignment. Now my name is Wong Chun Kit, S44364.
And my name is Nur Siti Aisyah binti Nur Azaimi, S51043.
I am Nur Saidra binti Muhammad Saidi, S52312.
My name is Naima bin Samsudin, S50238.
Okay, now let's begin. Okay, now before we branch deeper into our assignment, now let's look at what is Cramer's rule. Now Cramer's rule is an explicit formula for the solution of a system of linear equation. Okay, however, the system must have a unique solution, and then it expresses the solution in terms of the determinants of the square coefficient matrix and also the matrix obtained from it by replacing one column by the column vector of the right hand side of the equation. Now that is the general part of the Cramer's rule. Okay, now let's look on the example on the Cramer's rule where you can actually fully understand better. Okay, suppose we are given two system of linear equation. Okay, what we're going to do is we transform it into this form: ax equal b, where a is the matrix, now b is the constant. Okay, so from here we actually compute the determinant, which we get 6, and then we also compute the determinant for the a1b and the a2b. Alright, what basically happens here is we replace the column 3, 1 with 5, 2, which you get here, and you do the same for the other column, and then from there we find the determinant for a1b and a2b, which we obtain 5 and -1 respectively. From there we can compute the solution already just by using this formula: determinant of the a1b over the determinant of the original matrix, which is a. So from there we get the solution for x1 is 5 over 6, and the x2, which is -1 over 6. Right.
Okay, next, we look the applying Cramer's rule in the real life. Okay, we can see the real situations in our daily life, and that's we construct by ourselves. Wong and Co are selling nasi lemak dinners for 5 ringgit and chicken chop dinner 10 ringgit at the night market. Suppose Wong and Co know that they sold 200 dinners and makes 1,300 ringgit. The problem is that Wong and Co forgot to keep track of how many of each type of dinner they sold, and they need to know that in order to better predict how to shop for the next times. How many of each dinner did they sell? So we look for the solutions. First, we let x1 equal to number of nasi lemak dinner sold and x2 equal to number of chicken chop dinner sold. So from the problem statement, we can conduct the equations, two equations: x1 plus x2 equal to 200 and 5 x1 plus 10 x2 equal to 1,300.
Okay, so from the from the matrix that we computed earlier, here we have ax equal to b, which is its general formula for matrix. So here we have 1, 1, 5, 10, which is matrix A, x1, x2, which is matrix for x, and we have here 200 and 1,300 for matrix B. So here we find the determinant of A first, which is we compute A multiplied by 10 minus 1 multiplied by 5, which is we got 5. And then, okay, by using Cramer's rule, we substitute matrix B into the column 1, which is here we get here 200, 1,300, 1 and 10. So for determinant A1B, so we do the same operation as determinant of A, which is we get 700. So as for A to B, we substitute the matrix B into the column number 2, And then here what we got. And then we just compute the determinant of A to B, which is 300.
So x1, we just substitute. Then we get 140. For x2, we get 60. From this, we can conclude that Wong and Co. for 140 nasi lemak dinners and 60 chicken chop dinners.
That means we actually sold 140 nasi lemak dinners and 60 chicken chop dinners.
Thank you.
Thank you. Nice.